Yes guys, welcome back to the channel on this lovely beautiful morning actually. Welcome to Harry's cleaning this week. So Chris's build. So quite a bit of progress made this week. Some's been cleaned. That was a fairly long process. Just quickly show you that now. So yeah, so more cleaning to be done. This is Chris's sump. It's a baffled sump, iBed one. We need to get this lashings of sealant off. So I'm going to take his baffle off. Put it in for a soak and get this looking like new. Still quite a bit to be taken off. There was a lot of sealant in here, but again you can just see where they've pried the sump off. That bit there will need to be flattened. Yeah, this all needs a good clean. So what I'll do is I'll brake clean this first, just so we're not getting too much contaminant in there. So there we go, it's had a brake clean. So we're just going to give it a good soak. Kerosene actually helps as well to soften the sealant. So we just need to clean out all these holes now, and then give this a bit of P600 just to smooth it off. Another top tip: if you've got an iBed sump, you see this all the time. If you've got an iBed sump, people always use an 8mm to get in there, and they end up rounding it off. As you can see, it's not 8mm; it is 5/16. I mean, this one's in a bad way. Might have to get a new sump plug for that, but it is a magnetic sump plug. Yeah, always see these rounded off, and it's because they're using an 8mm, and it's not 8mm, it's metric 5/16, imperial, sorry, 5/16. I'm just running over it with some P600 again, to make sure we got a nice mating surface. And again, yeah, you can just see where they've pried the sump off here, and just have to flatten that down. And there we go. So that's how we want it. Nice and clean. There are, and I did have to sand this down quite a lot. You can just see these little scratches. You can't actually feel them, so they're alright, but hell of a lot of scratches on it. It'll take a while. So you see where we've flattened it off. But yeah, so that is ready to go back on the car. So oil pump all cleaned. Check for movements. His boost pipes have been all cleaned. His dump valve. So his auxiliary bracket, which houses the oil filter and whatnot, that's obviously been cleaned. We have got to take this heat exchanger off because we've got a new oil cooler that replaces this. It's a take-off plate version. It's much better than the racing line ones. These tend to affect oil pressure, whereas these don't. So I've got that to do today. Remove his old racing line kit. That's going to be for sale if anyone wants a bargain. Chassis being cleaned. So if you remember in the last video how rammy all that was. Even done his bonnet as well. So that's nice and cleaned. And I've just got on the bench here his billet manifold, intake manifold. So this runs a ported methanol system as well as one in his charge pipe. So I am going to test these injectors, just make sure they're spraying right. But I've got it on the bench because you can just see where I've just started cleaning it. So we'll get it all nice for when the engine gets put in. Anyway, the engine, so quite a few little issues. So we'll just nip over to the other unit and I'll show you his cylinder head, the differences, and then we'll show you the issues we had with his bottom end. So let's get that. Okay, so this is Chris's cylinder head. You can see it's not very clean. See his PCV galleries there. So his catch can has been left quite full. But yeah, so basically we need to clean all this sealant as we did with his head cover. What I've got to do now is just strip all his valves down. And you can see he's got beehive APR springs on this. So the beehive, obviously stiffer springs, and you can just see where the diameter of them lower down tapers off to the top. So yeah, bit of a boring job. Well, I've got to basically strip everything off. We've already taken his coolant outlet, temperature sensors out, strip all this down. We can see as well, has this been ported slightly? Yeah, this has been opened up. So the way to tell is, if you can see the line of his gasket, typically it's about, I don't know, 2 mil inwards, the gasket. So this is actually been ported and opened up. It's just something we do. Yeah, they haven't really ported the top very well though, but they have opened it up, which is one good thing. Let's have a look. Actually, there's quite a bit of, I mean, they're fairly clean. So, yeah, so one of the things we do in ours when we do these cylinder heads is we actually blend where the dividers go in, the air dividers. I've got some somewhere. I have got some, I've just seen some. So yeah, so where these slide in, oh, wrong way, where these slide in like so, we actually remove these from our big builds because you don't need them, especially if you're running an RPC intake. And yeah, we blend all these in because they will cause turbulence up. So you can just see his PCV, which is positive crankcase ventilation. So stop PCV, obviously, I think on low idle, idle and low RPM, it will divert crankcase pressure, ventilation, sorry, to here, which obviously, if you see the channels come out and go back through the intake where they're reburnt. But yeah, it's interesting that they've left these out. I haven't really got an example to show you other than the next engine we do that's ported. But yeah, I mean, the back of the valve seats are have been ported out. It's just strange how they've left them like that, really. Anyway, let's crack on. Let's get these valves off. There we go. So you can see, as I said, a beehive design. And we're just going to push this valve out, line them up. Some more space, really. So yeah, so the reason why we use stiffened springs or uprated springs when we build heads is just as I said, what we call the beehive shape. You can see where the spring tapers down. So the reason why we use these springs, I mean, these are stiffer springs. What happens at high RPM with the stock springs is they can't decompress quick enough to allow full operation of the valve, sorry. So we call it valve float. So that typically happens around 7,400 RPM. So if you imagine, if you got a big turbo, obviously the boost comes in much later, You're shortening your power band with stock springs. So by putting stiffer springs in, it means you can just extend that rev limit to 8,000 RPM, and you're lengthening that you know what power you can get across that power band. A lot of turbos make, you know, peak power right at the end of the RPM. So if you're running a big turbo and you're building your engine, it's definitely worth getting at least stiffer springs. Yeah, on the intake usually there's two, and you see where they've cut away there, there's two like casting marks, and obviously by opening this up you're getting about 30% better flow. Just while I remember, you can see the casting mark here on the intake. This is what we brought out, so it's flush with the valve seat. There's quite a bit of increased airflow just from that porting alone. So it is a stock head, got a strip and clean. We send this away to porting. If you see what I mean about the on Chris's, how the exhaust is opened up. So what I'll do is I'll just show you this marked up against Chris's head. So yeah, so you'll see the difference. This is where we can see the inside of the gasket, and then we can see Chris's head, which has been bored out. And this is what we do, we bore it out right to the edge of the gasket. Just helps flow that exhaust a bit more, which is what you want when you're running a big hefty turbo. When we do it, it's a 3mm circumference. But yeah, you can just see the difference, can't you? Anyway, I've got to strip this one down. Not going to show you that because it's just the same process. It's just going to be boring, isn't it? So a bit of bad news for Chris. So this is the con rod that took the brunt when the piston melted. You can see the alloy still on the con rod, which isn't a problem, you can clean that up. But the issue is it's slightly distorted. So when we put the wrist pin in, all the others went in smoothly, but this one is slightly distorted on the edge here. So that is going to be new con rods, unfortunately. Yeah, shame. Yeah, bad news. Anyway, we are just doing the ring gaps. Well, Dave is. So obviously this is his block, which we've supplied because the old one, obviously I think it was cylinder 3, wasn't it, Dave?
Yes.
Yeah, it was, yeah. It melted the piston and obviously took out the bore of the cylinder quite deep, so we couldn't reuse it. So this is a block we've supplied, which has been freshly machined and honed, oversized to 83mm. And here is the piston in question, which it's literally been in the fires and moored all that, hasn't it? It's a proper job. Yeah, unfortunately it has distorted the tip of the con rod, so I would not want to put that in. Here's Chris's block, which has been freshly bored, oversized by 0.5mm. So we're just doing the bearing clearance. Now it is super critical, this part, and if you look, I don't know if you're going to be able to see that, but on the end of the block, just here, we have got codes. So we got R, S, S, R, R, and what this means is all these blocks is basically different from factory. So you can see, let's just get a light, you see you've got a little red mark on that one, black on that one, black on that one, red red. So R is obviously code for red or rot in German. S is German for black, schwarz. Red, black, black, red, red. So you can see we're just going to lay a slither of plastic gauge on each bearing, and then we're going to torque the crank down, and then that will give us our clearance once the crank basically crushes and squashes out the plastic gauge. So here's Chris's crank. We get all these cranks checked for straightness. We just polish the journals so it's ready, but you will see just at the bottom here some more codes. So this is BBBBB, which means the lower mains, which is the end caps here, will be blue colour coded. So you have to make sure you check the crank, and again same tolerance. So now we're going to torque this down to spec, and that plastic gauge is going to flatten and show us what our clearance is. Just over a thousandth of an inch. It's pretty much the same story. Oh. All of them. So yeah, so we're happy with that. That is in spec. Now we need to take the crank off and check the bottoms. So yeah, we've got a little friend in the shop. Anyway, so we've done our tolerances on the mains. We were waiting for rods because obviously the rod was distorted. We have got new rods now. He's just sent us these yesterday with new wrist pins. However, we'll do a bit of alteration because the wrist pins don't exactly fit, but Dave's going to sort that. Yeah, really important you do the correct tolerance on these, because the tolerance is super tight. On the mains, the tolerance is 0.017mm to 0.037mm, which is between a thou and a thou and a half. It's really critical because the main middle bearing actually feeds your turbo oil pressure. So if you've got a slack tolerance here, or out tolerance, you're going to lose oil pressure and lose oil pressure to your turbo. So that's why everything has to be checked, it has to be right. So I'm just going to measure the axle radius. So that's just what walk we've got on the crank, which we shouldn't have any because we've got new thrust bearings, but something we do with a DTI gauge wherever I put it. Yeah, so we're going to set this up. I'm just going to check the run out as well of flywheel side. So we should see more or less no movement on that. You'll see ever so slight movement, but there shouldn't be any really. So yeah, get cracking with that. Okay. There we go, so that is well within tolerance. So the tolerance for that is 0.070 to 0.231mm. Well within that. Now we're just going to check the run out of the crank. As you can see, we are almost very perfect, but again, miles within tolerance. So we've got our bearing clearances done for our mains. Axial tolerance is in. Run out is good, so we're just going to put in the rods on the pistons. So all the squirters are in. So yeah, rods and piston time, and then we can start building this engine. Once we've done the head, we'll all be good to go. So did weigh all the pistons, which is why they got writing on them. And what we need to do now is just match them up with the wrist pins. So how we do this, as you can see, this one is the lightest piston. It means 0.21, which is milligrams. That one's the heaviest piston, 0.69. And then we got two pistons identical to each other. So if we have a heavier wrist pin, we put the heavier wrist pin with the lightest piston. If we have the lightest wrist pin, we put it with the heaviest piston. So that is what we're going to do now. So we got 132.11.